So what we've done so far is we've talked about how to find the number of valence electrons. And there are two different ways. One is to write the electron configuration for a specific element. And then what you do is you note that valence electrons are the electrons that occupy the outermost energy level. So you find the outermost energy level and you just count. Now the other way to do it that we talked about is to remember the pattern, to remember the trend. So in group 1 right here, you've got one valence electron. Okay. Got one valence electron. In the second group, you've got 2. You skip the transition metals. Then in the third, you've got 3 valence electrons, 4. So it's a pretty nice and easy trend that you can remember. So you don't have to write out the electron configuration every single time. All right. Now, I'm going to explain Lewis dot diagrams to you. You're just going to be introduced to them. We're not really going to use them extensively until the next unit. So what a Lewis dot diagram is it's a depiction of the number of valence electrons that an atom has. And now the way that you write it, you first write the symbol, the chemical symbol for the element, and then you can fit up to 8 valence electrons around that symbol. So you can fit 1, 2, 3, 4, 5, 6, 7, 8 valence electrons total. All right. Now, a lot of the time, no, you won't need 8 valence electrons. The way that you fill a Lewis dot diagram, some people are picky about how you fill it. It doesn't really matter to me as long as your dots are clear. So I'm going to show you for potassium what I would do. The symbol for potassium is K. All right, and since it is in group 1, it has only one valence electron, and so I'm going to draw just one dot. Now, you could draw the dot up top, on the side, either side, on the bottom, it doesn't matter. I'm going to draw it up top. All right, for sulfur, this chemical symbol is S. All right, and if you look at sulfur right here, it's got 6 valence electrons. Now, the way I'm going to fill it, I'm going to put 2 here, 2 on this side, and 2 on the bottom. You can fill it any way that you want, just remembering that on the top, the bottom, and each side, you can only fit 2 valence electrons. So what I want you to do right now is I want you to pause this video, and I want you to write the Lewis dot diagram for Krypton. All right, and then I'll move on. Okay, so the other thing that I'm going to explain to you today, in addition to Lewis dot diagrams and reviewing how to count the number of valence electrons, is the charge of an ion. Because each element, when it forms an ion, for the most part, we can predict what the charge of that ion will be, except for your transition metals, most of your transition metals. So we're just going to deal with these guys right here. All right. So what I'm going to do is I'm going to explain with fluorine how we determine charge. I'm not going to deal with valence electrons right away, even though that will help us to determine the charge. I'm going to draw instead the Bohr model diagram to make sure we're on the same page. So fluorine has 9 protons, which means that when it is an atom, it needs to have 9 electrons as well. So that's the nucleus. I'm going to draw the first energy level, and remember, in the first energy level, you can only fit 2 electrons. So I'm going to draw one here and the second one here. Now, in the second energy level, because I want a total of 9 electrons, since I have 2 already, I'm going to draw 7 electrons. Now, the goal of any element is to have the electron configuration of a noble gas. All right. What that means to have the electron configuration, to have the same number of electrons as any noble gas, what that means is that your element, whatever you're dealing with, when it becomes an ion, it wants to have a complete energy level. All right. So you have 2 different options. In this case, it could lose all 7 of these electrons. It could lose 7. So that if it lost 7, it would be 1, 2, 3, 4, 5, 6, 7. It would have the electron configuration of helium with only these 2 electrons, but a complete energy level with just 2. Or it could simply gain 1 electron, because this would then be complete because it would have 8 valence electrons. Now, just from a numbers point of view, it should be pretty obvious to you that gaining 1 is easier than losing 7. So what fluorine does is that it will gain 1 electron. So if you are gaining 1 electron, you will have a negative 1 charge. Now, every single time you're trying to determine the charge of an ion, you should not be having to draw out the Bohr model diagram. This was just to explain to you why it gains 1 versus loses 7 and why and where in the world I got these numbers from. All right? Instead, what you should be doing is the following. You should say, okay, I've got fluorine. It's right here. It's got 7 valence electrons. Now, the goal of any element, when it becomes an ion, it is either going to end up with 0 valence electrons, because if you think about it, it could lose all of these 7, okay, to get 0, technically, or it wants 8 valence electrons just to gain 1. So it can either lose all of them and go down 1 energy level, which would be complete, so technically 0 in that outermost energy level that previously existed, or it could gain enough to get a full energy level, which would make 8. All right? So I'm going to do phosphorus and I'm going to do calcium with you, just to make sure we're on the same page. So for phosphorus, if you look at phosphorus, phosphorus has 5 valence electrons. Okay, so I'm going to write that right here. Now, phosphorus can either, to get to 0, it can either lose 5 valence electrons, or it could gain 3 to get 8 valence electrons. So just from a numbers point of view, it's easier to gain 3, which means if phosphorus is gaining 3 electrons, its charge is negative 3. All right? For the next one, calcium has 2 valence electrons, which means it could either lose 2 electrons to get 0, okay, and I put that in quotes, 0 valence electrons, even though it will have valence electrons, obviously. It'll have 8 in the end, but the point being it's going to lose the 2 outermost ones that it currently has, or it could gain 6. Now, from a numbers point of view, losing 2 is easier than gaining 6. So calcium, which has 2 valence electrons, will have a +2 charge because it's going to lose 2 electrons. And when you lose 2 electrons, you have a +2 charge. So what I want you to do right now, for homework, you need to complete nitrogen, you need to complete argon, and I need you to do potassium. And that's all there is. All right?